You know, there's a funny thing about science that most people don't realize. The equations don't change how people see the world. Stories do. If you tell someone that light behaves like a wave and a particle at the same time, they'll nod politely and forget it by dinner. But if you tell them a story about a physicist arguing with himself, getting confused, making a wrong turn, and then suddenly seeing something click, well, now they're listening. And more importantly, now they're thinking. So let me start with a question that sounds almost disrespectful. If science is supposed to be about facts, why do stories matter at all? If the laws of nature are written in mathematics, why bother telling stories about people fumbling around trying to discover them? That question bothered me for a long time because I noticed something strange. Whenever I explained physics by starting with the result, here's the law, here's the formula, here's the conclusion, people would accept it, but nothing inside them really moved. But when I told them how we found the idea, including all the confusion and mistakes, suddenly they felt like science was something humans actually do, not something handed down from the sky. And that, I think, is where people's view of science quietly changes. When I was younger, people thought science was a kind of finished book, a big one, written by geniuses full of answers. Your job was to read it carefully and not smudge the pages. But that picture is completely wrong. Science is more like a conversation that never ends, where every answer creates 3 new questions, and half the time we don't even know which question we should be asking. One of the first times I noticed this gap between how science really works and how people think it works was when I was teaching. A student came up to me after class and said, "Professor Feynman, I understand the formula, but I don't understand what it means." And I remember thinking, good, that's an honest statement. Most people stop at the formula and never even realize they're missing something. So instead of repeating the explanation, I told them a story. Not about electrons or fields, but about watching people at a train station. Some people rushing, some people waiting, some changing direction for reasons you can't see. I asked him to imagine tracking all of that motion, not by memorizing where everyone went, but by understanding the rules that made them move the way they did. And slowly I could see his face change. Not because he memorized something new, but because he started seeing differently. That's what stories do. They sneak understanding past your defenses. People often ask me why I told so many stories, as if storytelling were a distraction from the real science. But I never saw it that way. To me, a story is just a thought experiment with people in it, and thought experiments are one of the most serious tools we have. Take one of my favorite examples. You've probably heard the story about the Space Shuttle Challenger. Most people remember it as a tragedy, which it was. But what changed how people saw science wasn't a report or a graph. It was a story involving a glass of ice water and a rubber O-ring. I stood there in front of the commission, dipped the rubber into ice water, and showed that it lost its flexibility. No equations, no complicated analysis, just a simple demonstration. And suddenly something clicked, not just for the engineers, but for the public. They saw that physics isn't abstract. It's brutally physical. Materials don't care about schedules or optimism or political pressure. They behave the way they behave. That little story did more to communicate scientific honesty than pages of technical explanation ever could. And here's the part people miss. The story wasn't meant to be dramatic. It was meant to be clear. Drama was just a side effect of clarity. Let's pause for a second and check whether we're on the same page. Suppose I told you science proves this is safe. Would you believe me? Maybe. But if I told you a story showing how someone tested it, what they expected, what surprised them, and what almost fooled them, now you'd have something stronger than belief. You'd have understanding. That difference between believing and understanding is the thin line where science either lives or dies. When I talked about physics to non-scientists, I always tried to smuggle that idea in. Not by lecturing about philosophy, but by telling stories that exposed how fragile knowledge really is. How easy it is to fool yourself. How tempting it is to stop asking questions once you get an answer you like. There's a story I like about names. I used to say you can teach a child that a bird is called a sparrow in English, a spatz in German, and something else in another language. But after all that, the child still doesn't know anything about the bird. They don't know how it flies, why it sings, or how it finds its way home. They know a label. That's all. That story upset some people. They thought I was attacking education. I wasn't. I was attacking the confusion between naming and knowing. And once people heard that story, they couldn't unsee it. Suddenly they noticed how often we hide behind words instead of understanding. This is where science quietly stops being a subject and starts becoming a way of looking at everything. Another story people remember is about the plate spinning in the cafeteria at Cornell. I noticed that the wobble of the plate and the rotation weren't synchronized the way I expected. I started playing with it, calculating ratios just out of curiosity. No big goal, no grand theory, just a puzzle that bothered me. That little game eventually led me back into serious physics, and not long after, to work that earned me a Nobel Prize. But if I told the story starting with the Nobel Prize, you'd miss the point entirely. The point is that science often starts with play, not ambition. That story changes how people see discovery. They stop imagining scientists as people who sit down and decide to revolutionize the universe at 9 a.m. Instead, they see someone getting annoyed by a wobbling plate and refusing to let it go. Let me ask you something. When was the last time you followed your curiosity without knowing where it would lead? Not because it was useful, not because it would look good later, just because something didn't sit right. That's science at its most honest. Now here's a common misunderstanding I want to gently poke at. People think science is cold, mechanical, devoid of emotion, but the stories tell a different truth. Confusion, frustration, delight, these are everywhere in real science. The difference is that scientists are trained not to let their emotions decide what's true. You're allowed to fall in love with an idea. You're just not allowed to protect it from reality. That principle shows up again and again in the stories I told. Whether it was about cracking safes at Los Alamos or questioning textbooks or admitting publicly that we don't actually understand something as well as we pretend to. Each story carries the same quiet lesson. The easiest person to fool is yourself. And once people really hear that not as a slogan but as a lived experience, they start seeing science less as a collection of facts and more as a discipline of honesty. Let's try shifting the context and see if the idea still holds. Imagine you're not doing physics. Imagine you're listening to a news report or reading a confident opinion online. If you only hear conclusions, you're being asked to trust. But if you hear the process, the doubts, the assumptions, the limits, you're being invited to think. Science at its best invites thinking. Stories are how that invitation gets delivered. By the time I was older, I realized that people weren't really quoting my equations. They were quoting my stories. And at first that bothered me. I thought, shouldn't the physics matter more than the anecdotes? But eventually I understood. The stories were doing their job. They were changing how people approach knowledge. Instead of asking, what's the right answer, they started asking, how do we know? And that question, more than any fact, is what keeps science alive. So here's what I'd like you to try just once. Take a scientific claim you believe, anyone, and instead of repeating the conclusion, try telling the story of how someone might have figured it out, where they could have gone wrong, what they had to check twice, what surprised them. If you can do that, you don't just know the science. You're starting to see the world the way science actually sees it. And if you want to keep exploring these stories together, we can keep pulling at them one thread at a time. Or we can take one idea and test how far it really goes. Either way, remember, this science doesn't change minds by shouting facts. It changes minds by quietly teaching people how to think one story at a time.